In a previous video, we looked at a joint distribution, and from that joint distribution, we were able to find the marginal distribution and the different summary statistics. What we want to do in this video is take that same joint distribution and the resulting marginal distribution, and we want to find the conditional distribution. So when we think of the conditional distribution, we're going to think of Bayes' law. And so that tells us that the probability of A condition on B is equal to the probability of A and B divided by the probability of B. As we think of the case of two variables that are continuous, one way to think about this is simply the joint distribution divided by the marginal distribution. And so in this case, if we want to find the conditional distribution of y condition on x, of y given that x is equal to some value of x, this is going to equal f of xy, which is the joint distribution, divided by the marginal distribution. So given that we know the joint distribution, that is 9/10 x y squared plus 1/5, and we divide that by the marginal distribution, which we found to be 3/10 x plus 1/5. And so that's how we're going to set it up to find the conditional distribution. Now we can simplify, multiply the top and bottom by 10, and that's going to allow us to get a more simplified version of the conditional distribution of 9x y squared plus 2 divided by 3x plus 2. And this is going to be for when y is contained between 0 and 1. And so this is the marginal distribution, or the conditional distribution of y given x. So if we were to ask the question, what is the distribution of y given that x is equal to 0.5? Well, if this is the question, we can simply use our conditional distribution to say that this is equal to, well, now we're just going to put in 0.5 where we see x. So we'll have 9 times 0.5, y squared plus 2, over 3 times 0.5 plus 2. And we work to simplify this, and this will be 9y squared plus 4 all over 7. And this for when y is contained between 0 and 1. And so we can use the conditional distribution and plug in a value of x, or leave it like we did right here as just a function of x, which is now a parameter. Well, we might not stop with just the distribution. We might ask ourselves, what is the expected value of y given that x is equal to 0.5? Well, we'll follow the similar pattern that we had before. This is going to equal the integral over the domain of y times the conditional distribution of y, given that x is equal to 0.5 dy. So again, it's just our value of y times the distribution. And so we can then now start adding some numbers. This is equal to, y goes from 0 to 1, of y times 9y squared plus 4 over 7 dy. And this is coming from this part right here, because we know that x is equal to 0.5. Now we'll just integrate from here. And so this is equal to 9y to the fourth over 28 plus 2y squared over 7, evaluated when y is from 1 to 0. So this is equal 9 over 28 plus 2 over 7, 17 over 28, or 0.6071. And so there we have the expected value of y, given that x is equal to 0.5. Well, if we found the variance of, or the expected value of y, well, the next question is, well, can we find the variance of y? And we should be able to, where we know that the variance of y is equal to the expected value of y squared minus the expected value of y quantity squared. So we just solved for this part, so now let's solve for the expected value of y squared. So the expected value of y squared is equal to the integral from 0 to 1 of y squared times the distribution, the conditional distribution, which is 9y squared plus 4 over 7 dy. We bring this through and take the integral. We'll get 9y to the fifth over 35 plus 4y to the third over 21, evaluated where y is equal 1 to 0. This will equal 9 over 35 plus 4 over 21, which is about 0.4476. Now this isn't our variance, this is just the expected value of y squared. So now we have to then input the numbers we have for our variance. So the variance of y, condition on x is equal to 0.5, is equal to, and I guess I should probably make note here, this is not just the expected value of y squared, this is the expected value of y squared given that x is equal to 0.5, right? And that should be the same thing here. This is the expected value of y squared given that x is equal to 0.5. And so now we get the expected value of y condition, or the variance of y condition that x is equal to 0.5 is equal to 0.4476 minus 0.6071 squared, which is equal to 0.0790. So that is our variance of y given that x is equal to 0.5. I could also then take that next step to find, well, what is the standard deviation of y given that x is equal to 0.5? And that I would just take the square root of 0.0790 to find that the standard deviation is 0.2811. So there we can find not just the conditional distribution, but we can find the expected value of the conditional and the variance of the conditional, given a joint distribution, a marginal distribution, and the information we have there. So one thing to note real quick is if we want to compare, notice that the expected value of y is equal to, so this is the unconditional. So this is 0.65. However, the expected value of y condition that x is equal to 0.5 is equal to 0.6071. So knowing that x is equal to 0.5, we can update our expected value of y and get a different number than just the unconditional expected value of y. Similarly, the standard deviation of y, unconditional, is 0.2661, but the standard deviation of y conditioned that x is equal to 0.5 is equal to 0.2811. So again, with more information about x, we can update our estimate for the standard deviation of y compared to the unconditional. So in this case, knowing that x is 0.5, the expected value of y is lower than the unconditional, and the standard deviation is higher. And this is because x and y are not independent, so by having information on x, I can more accurately estimate my expected value and standard deviation of y.